All right. Okay, good evening. Assalamualaikum. All right. So we continue still in chapter number 9, Simple Linear Regression. So last class, we have looked at how to uh, perform or calculate a regression equation, right? Remember, regression equation for simple linear regression, y equal to b beta naught plus beta 1 x, right? And then to assess whether x and y have a relationship, right? So we can measure using a standard error of estimate. By using standard error of estimate, we can calculate standard error of the slope to test whether x and y has a linear relationship or not, right? And then we have looked at into coefficient of determination. Remember R square. So R square explain how many percent that x is explained in total variation in y can be explained by x, right? And we have looked into t-test of the slope, right? So today we're going to look at another method to assess the fitness of the model, right? Whether x and y can do a prediction of or not, right? Means that whether the model is fit to do a prediction or not. So by using analysis of variance approach, so we call as ANOVA. So this is a short name for analysis of variance, right? So another way to test the significance of regression. So testing for significance of regression. So null hypotheses are same as testing for the slope, right? So null hypothesis beta naught equal to 0, beta 1, and alternative hypothesis beta is not equal to 0. It means that there is no significant relationship between x and y. If we reject null hypothesis, to conclude alternative hypothesis, the straight line model is adequate or the model is fit for prediction. In this method, we are using F distribution. So we are not using T distribution, F distribution. Let me make a correction here. F distribution, where F is equal to mean square regression divided by mean square error, right? So mean square regression, we get from sum of square regression divided by K. K is number of variable. Mean square error, we got from SSE, mean square, sum of square error divided by N minus K, right? N minus K or N minus 2, right? So the criteria for rejection, so since we are using F distribution, the distribution of F is skewed to the right distribution because it's a combination. It came from a 2 chi-square distribution. So F is actually a chi-squared with degree of freedom divided by a chi-squared with degree of freedom. So we got F with 2 degree of freedom, right? So it's a skewed to the right distribution. So we need to find the critical region for this one. Critical value is F alpha, degree of freedom number 1, and degree of freedom number 2. So this is the rejection area. So if F calculated more than F alpha degree of freedom 1 and degree of freedom 2, means that if F calculated lies inside rejection area, we reject null hypothesis, right? So the ANOVA test for significant regression usually summarized in a table. So we need to construct an ANOVA table in order to get F value, F calculated, right? So this is a formula that we already learned last week, right? So SXX, SYY, SXY. So these formula are used to find sum of square error and sum of square total. And we can use this formula to find sum of square regression. And beta 1, beta naught, R square, and standard error of estimate. Right. So by using this formula, we can create ANOVA table. So ANOVA table, this is a standard ANOVA table, analysis of variance. So first column, we have source of variation. Second one, we have sum of square, degree of freedoms, and mean square. And last is F value, F statistics. Right. So in this table, we have 3 rows. The first row is about regression. The second row is error or residual. And the last row is total. Right. And of course, we need to calculate, use the formula to calculate sum of square error, sum of square total, and sum of square regression. For degree of freedom, the degree of freedom for sum of square total is n-1. Degree of freedom for sum of square error is n-2, and this is actually k lah. K is equal to 1. In simple linear regression, we only have one independent variable, so that's why k is equal to 1. Right, so this is number of independent variable. Right, so to get the mean square regression, we need to divide sum of square with the degree of freedom. So sum of mean square regression, sum of square regression divided by its degree of freedom. To get mean square error, sum of square error divided by its degree of freedom. Right. So to get F value, mean square error, mean square regression divided by mean square error. Right. So that is formula in the table. Okay. So we're going to use this value to find the model fitness of the regression model. Okay. Sudah? This one okay? Then, right, let's look at example number 12. So in example number 12, we look at example number 1. In example number 1, remember last week we have done it. Summation of x equal to 58.62. Summation of x square is equal to 291.231. Summation of y equal to 34.15. Summation of xy 169.2532. And last, we have summation of y square, which is 98.6967. And n we have equal to 12. Right, this is based on last week example, right? So remember, to construct one ANOVA table, right? So we need to find a sum of square regression, sum of square error, and sum of square total. So we need to calculate sum of square total. So, but before that, let's calculate each value first. Sum of sxx is sum of square x square. Sum of x square minus summation of x square divided by n. Right, this is 291.231 minus 58.62 square divided by 12. And you should remember, summation of x square is not equal to summation of x and then you square. Right, remember this. Right. Walaupun dalam test tu ada juga yang buat. Right. So this one should be equal to 4.8723. So this is based on the last example. So this is 169.2532 minus 58.62 multiply with 34.15 divided by 12. Another one is SYY, summation of y square minus summation of y, and then you square divided by n. So this is 98.6967 minus 34.15 square divided by 12. So this is equal to 1.5048. So this is also equal to sum of square total, right? Remember? So to find sum of square error is equal to sum of YY minus SXY square divided by SXX. So this is 1.5048 minus 2.4305045 square divided by 4.8713. So this is equal to 0.2954. Actually, this one we already calculated last week, right? Done? Right, so this is a table. So we plug in the value. Sum of square error is 0.2954. Sum of square total is 1.5048. So to get sum of square regression, we just minus sum of square total minus sum of square error. SST minus SSE. So this one should be 1.2094. Right. So the degree of freedom for regression is equal to 1 because you only have one independent variable. The degree of freedom for total is n minus 1. 12 minus 1 is equal to 11. This is equal to 10. Right. So 11 minus 1 equal to 10. Or you can simply get 12 minus 2. So this one, to get mean square, we just divide 1.2 divided by 1 should be 1.2094. This is 0.02954. Right. And then to get F value, we divide these two value. Mean square regression, MSR divided by MSE. So this one should be 40.94. So this is our ANOVA table. So based on the ANOVA table, we can test whether the model is fit for prediction or not fit. So to test whether the model is fit for prediction, null hypothesis beta 1 equal to 0. Alternative hypothesis beta 1 not equal to 0. Let alpha equal to 0.05. Test statistic F calculated should be equal to 40.94. Right? Okay, done. And then we look at the next step, which is critical region. So based on since we are using F distribution, so the distribution should be skewed to the right distribution. Right. So this is F alpha, degree of freedom 1, degree of freedom 2. So what is the degree of freedom number 1? Degree of freedom number 1 is degree of based on regression. Degree of freedom number 2 is based on error. So F 0.05, 1 and 10. So 1 is based on DF regression and this is DF error. So next step, we need to look at the statistical table. This one done? Done, right? Sudah? Any questions so far? Yes. DF error. We take from DF regression and DF error. So this is the degree of freedom number 1 and this is the degree of freedom number 2. We base on the this one lah, right? We divide from regression and error. So this is number 1, number 2. So we have 2 degree of freedom and this is our alpha 0.05. So based on table number 8. Kita pernah discuss this one before? Belum? So look at table number 8. So this is table number 8, right? Okay, look at this one. The first, we have degree of freedom number 1. For each rows, we have degree of freedom number 2. So since our degree of freedom number 1 is 1, so we look at first column, which is the F1. And we find degree of freedom number 2 is 10. So we need to find 10. 10 is somewhere here, right? So this is 1 and 10. So look at the first column, right? So this is our alpha. So if you look at this one, this is our alpha. So find alpha 0.05. 4.96. Boleh faham? This is 4.96. So our decision, if F calculated is more than F alpha degree of freedom 1 and 2, null hypothesis is rejected. Right? So since F calculated more than F alpha df1 df2, null hypothesis is rejected. So we can make a conclusion. The model is fit for prediction. Okay. Basically, that's all for ANOVA. Okay. So this is computer output for simple linear regression. Right. So we have the first table. This is on upper side. We have first table. We have predictor. The first value is constant and x1. This is the first independent variable. And this is the coefficient value, right? So from this, we know that y equal to 0.409 plus 0.499x. And this is a standard error of coefficient. And this is a standard error of beta 1. And this is a t value. So based on the p value, we can say that we can conclude that there is a significant relationship between x and y. In this case, x is a production. And this is a standard error of estimate. And this is a R square value. So based on the R square, we can conclude that there are 80.2% of the total variation in y can be explained by x, which is production. And this is our ANOVA table, right? So if you look at our ANOVA table and computer ANOVA table, the difference is the degree of freedom, the arrangement of degree of freedom and sum of square, right? Itu saja, yang lain semua sama lah. Right. Now let's look at example number 13. Let's look at example number 13. So estimate HFE when emitter RS is 1.45. So how to estimate? So we look at the first table at this is our equation, right? So y equal to 1075.2 minus 63.87x. So when x equal to 1.45, so we just substitute into the model 1775.2 minus 63.787 multiplied with 1.4, right? So this one should be 149.085. Okay. Second question, test for significance of regression for for alpha equal to 0.05. So to test for significance of regression, we look at the ANOVA table, null hypothesis, beta equal to 0, beta not equal to 0. Right. Alpha 0.05, test statistic, F equal to 63.70. Boleh eh? You know how to get F value from this table, right? Okay. And then our critical region. Oh ya, ya, okay. Sebab I punya nota 14, I salah tulis. So berapa you dapat? 982.5885. Right, okay. So this is a critical region. The rejection area should be on the left, on the right hand side, always on the right hand side. So F equal to 0.05, degree of freedom 1, and number 2 is 18. Right. So look at the statistical table. 18, cari 18 lah. So 0.05, 18, 4.04. Yeah. So our decision, right? Later you can see, you can do your assignment. Right? Available in you learn. Right? Submission date 26 July. Lagi 6 hari. Boleh? So conclusion. Okay, done? Sudah? Belum? Hey, don't forget to sign in your attendance. Yeah. Okay, done? So look at example number 14. I think you can do by yourself. This is based on... Huh? Sudah ke belum? So let's look at example number 15. Okay, boleh? So fill in the missing values. So how to find sum of square error? 785 minus 19. So this one 695. Right? And this one should be 30. This one. What is a mean square regression? Mean square error? 21.0606. 4.2734. Right. So how large do the sample? Should be 35, right? You know how to find 35, right? So how to find coefficient of determination? From the table, how to find coefficient of determination? So how to find coefficient of determination? This one should be sum of square regression divided by sum of square total. So 90 divided by 785. So this one should be equal to 11 point. Yeah. Because R square should be expressed in percentage lah. So how to interpret this one? There are 11.46% of the total variation in Y can be explained by X. So find the standard error of estimate. So how to find standard error of estimate? Yeah. Do you know? This one should be equal to sum of square error divided by n minus 2, and we take a square root. So this is also equal to square root of MSE. So this one should be square root of 21.0606. 4.589183. Right. At 5% level of significance, what can you conclude from the table? Estimated what? Yes. First need to state from null hypothesis and alternative hypothesis lah. Beta equal to 0. Alternative, beta is not equal to 0. Alpha 0.05. Test statistic. F equal to 4.2734. Right. And then your critical So F alpha, F 0.05, 1 and 33. This one should be equal to 4.08. Right. So since the F calculated is more than F alpha degree of freedoms, null hypothesis is rejected. So we can conclude that the model is fit for prediction. Yes. You don't have 33, man. So tak ada eh. So we can take from 30 lah. Tapi basically in test or final exam, you can find the degree of freedom in table lah. Test tu 35, right? Itu soalan yang tak buat kan? Tapi for final exam, you should find the value in table. .17. So you should reject lah. This one is 4.27. Still accept. Because if you look at the table logically, you tengok this is 30, so we have 4.17, right? So if you look at degree of freedom number 2, 40, 4.08. Right, so dia lagi kecil kan? So our F calculated is more than right, so we reject null hypothesis. Dia ambil yang paling rendah yang bawah. So 117 lah. So I letak sini 4.08. So 4.17. Alright, done. Any questions so far? Yes. And this one alpha tak bagi dua sebab just one tail. So now let's look at example number I think 16 you can do by yourself. Look at example number 17. You cepat sangat lah. Dah nak habis dah. So example number 17. So based on example number 17, we have stories and height. So what is independent variable and what is dependent variable? Dah tulis dah kat sini. Right. Okay. Should aware lah what is dependent variable and what is independent variable. Must be aware before we start analyzing data. Right. So compute the estimated regression coefficient of a linear model and state the fit equation. So how to find linear regression equation? So we need to calculate summation of x square, and so on, right? So y equal to beta naught plus beta 1 x. So beta 1 is equal to s xy divided by s x, right? And beta naught is equal to y bar minus beta 1 x bar. So Sxx is equal to summation of x square minus summation of x square divided by n. So this one should be equal to, so you plug in the value into calculator. Dia bagi value belum? We don't have the square value, right? So from this, we know that this is a Sxyy, right? From ANOVA table, sum of square total is equal to Syy. So we need to calculate Sxx. So input into your calculator. You jangan salin, you try to find by yourself. So kalau you tak cari sendiri, that's why in near to test tu you akan kelang kabut, and then test you tak boleh jawab. So this is based on SST, right? And next one is SXY. So regression equation should be 193.57 plus 9.33x, right? So this is a linear regression equation. This one done? Semua dapat? Buat sendiri. Dapat. Buat sendiri ada kita double check. Yes. Decimal point for equation, it depends on question lah. Sometimes it says 3 decimal point or tapi kalau dia tak cakap, you take 2 decimal point is okay. But when you do calculation, take everything. So we want to get accurate value, right? Ada compare sekarang. This one done, right? Sudah? Okay, dah? Done? So the second question is compute standard error of estimate. So how to compute a standard error of estimate for slope? Means that in this question we want to find SE for beta 1. So standard error for slope, refer back to your formula. It should be square root of sigma square divided by SXX, is it? So sigma square is equal to MSE, right? So this one should be equal to 4866.937. So standard error of beta 1 should be square root of 4866.937 divided by SXX, which is equal to 793.60. So this one should be 2.4764. Okay. This is 4 marks. Simple kan? Sama macam test 1, test 2. Right. So question 2, B and C and D, right? Simple kan? It's a repeated question. Just tukar alpha saja. Kalau salah, ya? Tak juga. Error tak bring forward lah. Tapi takkan you salah semua. Ya, ya, ya. Sama juga dengan this one, regression. Salah satu, semua salah. So, tengoklah kalau rasa kalau final exam, question number 5, we start with regression and then ANOVA. Salah regression, bring forward. Huh? Ada tanda dah. Nanti kita tengok. How about you focus on assignment and final exam? Okay? Don't worry about test. Test is pass. Alright, C. Kita siapkan ni dan kita take 5-minute rest. Right. C. How to compute percentage of variation in height of building? So this is R square, right? So R square SSR divided by SS total. So 69,072.901 divided by 108,008.400. So this one should be equal to 63.95%. So how to interpret? There are 63.95% of total variation in Y can be explained by X. I remember, soalan minta explanation means you need to explain. Sama macam test 2. Right? Final pun ada explanation. Tolak satu markah explanation. Sikit-sikit je kan? So next, predict height of building when X is 50. So our regression equation is this one. So when X equal to 50, this is D, right? So Y hat equal to 193.57 plus 9.33 multiplied with 50. So this is equal to 660.07. Right. So once you got the value, right, compare with the original table data. When X equal to 50, Y should be around 600 to 700 lah. Okay. Any questions so far? Tomorrow jangan lupa datang. Kita masuk multiple linear regression. So kalau tak datang, nanti affect your assignment. You tak boleh buat nanti. Yes? Huh? Masuk. Semua kita belajar, semua masuk. Alright. The last question. You see, this one. Listen. This one, based on your answer in D, when X equal to 50, calculate 90% confidence interval for mean change of height where number of stories is equal to 50. So remember last lecture, I already showed you the confidence interval. This is a confidence interval for slope, and this is a confidence interval for mean and prediction interval. So I don't think this formula will be in your booklet. Boleh refer balik the table. I don't think this one in your table, right? So, yeah. Apa? Ada? Ada, alhamdulillah. Bagus. Ada. Okay, good. Make sure you confirm, right? So this is a confidence interval for mean. We just y hat plus minus t alpha divided by 2 n minus 2 multiply with standard error of estimate multiply with square root of 1 over n plus x naught minus x bar square divided by sxx. This is a confidence interval for mean. For prediction interval, it's the same formula. We just need to add 1 for the margin of error, right? Right. So the confidence interval for mean, this is E. So y hat plus minus t alpha divided by 2 n minus 2. Standard error multiply with square root of 1 over n plus x naught minus x bar square divided by sxx. Right. So we want to find 90%, right? Alpha equal to 0.1. So let's collect the data. Y hat is equal to 660.07. Standard error of estimate is 69.76. So how to get standard error estimate? Square root of standard error of estimate. Square root of MS, right? So we already calculate this one, right? So square root of 4,866. What do you get? Should be 69.76. Okay. And then x naught is equal to 50 based on the previous example. X bar is equal to summation of x over n. So this one should be equal to 432 over 10, 43.2. So basically that's all. But this one, t alpha divided by 2 n minus 2, which is equal to t 0.05. Right? So 0.1 divided by 2 n minus 2 is equal to 8. So this one should be equal to 1.860. So once you already have the information, plug into the formula. So 660.07 plus minus 1.860 multiply with 69.76 multiply with 1 over 10 plus 50 minus 43.2 square divided by SXX is equal to 793.60. You should get probability of 660.07. Sorry. So we have 90% confidence that the mean change will be between 659 and 660. Bagus. Sekejap ya. So we can take 5-minute rest. So example ada berapa dalam ni? 21 saja, tak banyak. Dan this one dah sudah? Sudah? Right, can we continue? Boleh? So, kejap je, ada lagi 2 example dan kita habis. Right. So now let's look at example number 18. Hey, okay kah? So example number 18. So we have 2 variables, speed and time, right? So what is a dependent variable and what is independent variable? Typing speed and time. Independent. Yeah. So this is independent and this is dependent. Right. So obtain estimate regression function and interpret the meaning of slope. So as x, y, So slope we have y equal to beta naught plus beta 1x. Beta 1 is equal to sxy divided by xx. So this one should be 3163.8 minus 884 multiplied with 47.8 divided by how much? The data we have 12, right? So this one should be equal to 2606.66667 lah. So SXX is equal to 67728 minus 884 square divided by 12. So this one should be 2. I think this is wrong. Huh? This is negative 357.46667. So this is supposed to be 2606.666. So we just plug in the value into the formula. So we should get negative 0.1371355499. Oops. Right. And beta naught should be y bar minus beta 1 x bar. I should get 14.08565,211. Regression equation should be equal to 14.08 or 09 lah. 09 plus or negative 0.1314 x. So explain the meaning of slope. Beta 1 is equal to negative 0.14. It means that if x increase by 1, the time will decrease by 0.14. Right, so that one for A. And B, we need to test significance of model using 5% level of significance. So to test the significance of the model, we should use ANOVA table. Sum of square total berapa? SYY should be 51.66. Sum of square error, SSE is SYY. Can you calculate this one? This one should be berapa? 2 points. Right. So once you already have the F value, null hypothesis beta equal to 0, alternative hypothesis beta is not equal to 0, alpha 0.05, F equal to 184.94, critical region. So what is the value for critical region? 4.96. Right. So since F calculated is more than F alpha, null hypothesis is rejected. So we can conclude that the model is fit for prediction. Right. Okay, this one done. Dah. Okay, done. Right. For question D, question C, we need to compute the coefficient of determination. So this is very simple, okay? So R square is SSR divided by SSE. So this one should be 49.01 divided by 2.65 should be equal to 18 point. This is SST, right? So divide by 51.66 should be 94.87%. Explain the value obtained. There are 94.87% of the total variation in time can be explained by typing speed. In y is time, right? Can be explained by x. X is typing speed. Okay. So the last question, estimate the time it will take for average secretary who has typing speed 72. So our regression equation is y equal to 14.09. So this is our regression equation. Right, our x is equal to how much? 72. So y hat equal to 14.09 minus 0.14 multiplied with 72. So this one should be equal to 4.01. Right. So based on this value from this question, obtain 95% prediction interval of the time taken, right? So just now, based on example number 17, we want to find a confidence interval for mean change. So in this question, we want to find 95% prediction interval of time taken. So it's the same formula, but we need to add 1 plus. So y hat plus minus t alpha divided by 2 n minus 2, standard error, multiply with 1 plus 1 over n plus x naught x bar square divided by sxx. Right? So you plug in the value. But before that, we try to list down all the information that we need. Y hat equal to 4.01. T alpha divided by 2 n minus 2 is equal to T 0.0. This is 0.05, 95 n, 0.25. And degree of freedom is equal to 10, should be 2.228. Standard error of estimate is the square root of MSE. So this one should be square root of 0.26326 over 265, right? 265, and this one should be right. And then x naught is equal to 72. X bar, look at the value that we calculate. X bar is 884 divided by 12. Should be 73.67. right? So this one is formula for prediction interval. Kalau if we don't have one, it's a confidence interval for mean change. So another one is SXX equal to 2606.67. So just plug in the value. 2.228 multiplied with 0.5148 plus 1 plus 1 over 12. So roughly berapa you dapat? 3.0288 5.4088. So you need to calculate carefully. I think mine is sedikit lari salah. Right. Calculate balik. This is not really accurate. 2.81. 2 point. 2 point. Upper confidence limit. 5 point. Okay. So we have 95% confidence that prediction interval will be between 2.8 and 5.2. Okay. Done? Sudah? Right. Let's look at example number 19. You want to discuss this one or you don't want? Okay. Right. Example number 19. So we have area, square feet, and price. So which one is independent variable and which one is dependent variable? Price is dependent variable. X is independent. Area is independent lah. So based on the scatter diagram, right? Boleh nampak kan? Dah besar kan sikit. So scatter plot for above data is shown below. What can you say about the relationship between price and condominium, price of condominium and their build our area? It shows increasing from left to right. It means that there are positive linear relationship between area and price. Kalau if they are decreasing from left to right means there is a negative linear relationship. So we are looking into linear relationship, right? Just one mark. Okay. So the coefficient of determination was 0.979. So what does this tell you regarding the regression line? They are 97.9% of the total variation in condominium price can be explained by build-up area. So given that the sum of square regression is 108450.64, right? Doing whatever calculation necessary, construct ANOVA table for the above data. Right. So SSR is equal to 108450.64. So in ANOVA table, we need another information, SSE or and SST. So SSE is very complicated to calculate. We need to SYY minus XXY squared divided by SSX. The simple one is SST. So SST is equal to SYY. So we calculate this one. Summation of Y square minus summation of Y square divided by N. So this one should be 5612.125 minus 8125 square divided by how much? 12. So this one should be 110822.92. Remember, the sum square total should be bigger than SSR. It cannot be negative value. Huh? So by this information, then we can construct our ANOVA table. Source of variation, sum of square, degree of freedom, and we have mean square. So sum of square total is 110822.92, and this one should be 108450.64. Error should be the balance 2372.28. And then the degree of freedom, we know that n is equal to 12, this is 11. N minus 2 equal to 10, this is 1. Right. Mean square regression, just divide by 108450.64. This is 237.228. And F value should be 457.1578. Okay. So can you test the relationship between X and Y? Right, for tomorrow class, we will learn chapter 10, multiple linear regression. So before we start is chapter number 10, make sure you understand this chapter first. Right, so chapter number 9, simple. Chapter number 10, multiple. So if you understand this chapter, chapter number 10 should be very easy. Yeah. Okay. Ada soalan? Any questions so far? No question? Right. So example number 20 and 21, I think you can do by yourself. Right. Soalan? Ada soalan?